in this case, we solve an initial value problem by use of a method of undetermined coefficients. So the first thing is to get complementary solution by solving the homogeneous equation, then find the particular solution. Once we have these two, I will get the general solution and then use the conditions given at x equals to 0 to get the constants that will be present in this general solution. So homogeneous equation for this case is y double prime minus 2y prime minus 3y equals to 0. So let y equals to e raised power rx be the solution. So this means that y prime is r e raised power rx and y double prime r squared e raised power rx. So using these values in the differential equation, we'll have r squared e raised power rx minus 2r e raised power rx minus 3 e raised power rx equals to 0. So we'll have r squared minus 2r minus 3 e raised power rx equals to 0, which means auxiliary equation is r squared minus 2r minus 3 equals to 0. As we know, exponentials are non-zero. So product is minus 3, sum is minus 2, so numbers should be minus 3 and 1. So r squared minus 3r plus r minus 3 equals to 0. So r into r minus 3 plus 1 into r minus 3 equals to 0. R plus 1, r minus 3 equals to 0. So r1 is negative 1 and r2 is positive 3. So which means y1 of x is e raised power minus x and y2 of x is e raised power 3x. Now the complementary solution is a linear combination of y1 and y2. So which will be c1 e raised power minus x plus c2 e raised power 3x. So next step, we find particular solution. Now the g of x in this case is given by 36 e raised power 5x. So the guess or the trial solution for yp should be a e raised power 5x, where we need to find the value of the constant a. So with this now, the differential equation will be yp double prime minus 2yp prime minus 3yp equals to 36 e raised power 5x. Now yp prime is 5a e raised power 5x and yp double prime is 25a e raised power 5x. Now replace these values in this equation. So we'll have 25a e raised power 5x minus 2 into 5 a e raised power 5x minus 3 into a e raised power 5x equals to 36 e raised power 5x. Now this means 25a minus 10a minus 3a, then multiplied by 5 e raised power 5x should give us 36 e raised power 5x. So this will be 12a e raised power 5x equals to 36 e raised power 5x. Should be clear that 12a is 36, which implies a is 3. Now, so which means that yp of x is 3 e raised power 5x. So the general solution is always complementary solution plus particular solution, i.e. y of x is c1 e raised power negative x plus c2 e raised power 3x, now plus 3 e raised power 5x. So the initial conditions given will help us to find the values of the unknowns c1 and c2. So let's first get the derivative of this function. We'll get negative c1 e raised power minus x plus 3c2 e raised power 3x plus 15 e raised power 5x. Now, y at 0 is given as 9, which will be c1 e raised power negative 0 plus c2 e raised power 3 times 0 plus 3 e raised power 5 times 0, which implies 9 equals to c1 plus c2 plus 3, i.e. c1 plus c2 is 6. Call this one equation 1. Now from this y double prime at 0 from the equation, we have 25, which will be negative c1 e raised power negative 0 plus 3c2 e raised power 3 times 0 plus 15 e raised power 5 times 0, which implies 25 equals to negative c1 plus 3c2 plus 15, which means minus c1 plus 3c2 equals to 10. Call this one equation 2. Now from 1, c2 is given by 6 minus c1. So substituting into 2, we'll have negative c1 plus 3 into 6 minus c1 equals to 10. So minus c1 plus 18 minus 3c1 equals to 10. So minus 4c1 equals to 10 minus 18, which is minus 8. So c1 equals to minus 8 over minus 4, which is 2. And then c2 will be 6 minus 2, which is 4. So therefore, the solution, what we call specific solution, is y of x equals to c1 is 2 e raised power negative x plus c2 is 4 e raised power 3x, and then plus 3 e raised power 5x. So that is how we solve that initial value problem. Thank you.